Hello, my name is Evan Collins, and we're going to be talking about alcohols today. Alcohols are organic compounds in which the hydroxyl functional group is bound to a carbon atom. Alcohols are an important class of molecules with many scientific, medical, and industrial uses. In this video, we're going to introduce the functional group of alcohols and talk about the naming of alcohols and their physical properties such as boiling point and acidity. You're already familiar with lots of different kinds of alcohols, whether you know it or not. Classic alcohol, quote unquote, is ethanol, which is right here. And that is the intoxicant found in beer, wine, and hard liquor. There's also other alcohols, which is anything that contains an OH group. That's going to be considered an alcohol. And you could also have a compound, which this one is 2-propanol or isopropyl. You can also have really complex alcohols, such as OxyContin right here. You don't have to know how to draw that, just an example of a complex alcohol, so to speak. All right, so now we're going to start naming the alcohols. Here's some examples I drew over here to save time. If you have a 5-carbon alcohol, like any other compound, what you're going to do is account for the longest chain number. You're going to give alcohol the lowest priority. So this guy right here, that is going to be called 3-pentanol, or pentanethreol, and the 3 just indicates the position of the alcohol, so to speak. For the second drawing, this one is going to be 2-propanol, or isopropyl alcohol, which kind of mentioned that earlier, and that's a 3-carbon long chain with the alcohol being in the second position. And the next one is going to be tert-butyl alcohol. This one's going to be, tert-butyl alcohol. And another way to say it is 2-methyl 2-propanol. And as you can see, that's how it's drawn over there. And the next one, this one is called a benzyl alcohol or phenylmethanol. And this one is typically pretty common. And basically, I don't want you to know how to memorize these drawings. I just want you to be familiar with alcohols and know how to use the IUPAC names to name the alcohols, so to speak. And here's the examples here. And for the next part, we're going to be characterizing alcohols. And I want you to be able to identify, just for other functional groups, primary, secondary, and tertiary alcohols. So ethanol, which is right here, is going to be a primary alcohol. And then you see there's only one R group there. And then for the secondary alcohol, that is right there. And for that one, it would be an alcohol and a carbon bonded to 2 other carbons. And a tertiary alcohol would be an alcohol bonded to 3 other carbons. And I hope that makes sense. So we count the carbons bonded to the carbon with the OH to figure out, do you have primary alcohol, secondary alcohol, tertiary alcohol? We talk about the interconversion of primary, secondary, and tertiary alcohols, and certain primary alcohols might undergo reactions that tertiary alcohols will not undergo. So it's very important that you're able to identify primary, secondary, and tertiary alcohols to determine which kind of reaction that they're going to undergo. Just to make clear, with primary, you only have 1 R group. Secondary, you have 2 R groups. Tertiary, you have 3 R groups. And make sure you count carbons that are bonded to the carbon with an OH. That's how you look at that. All right, so next up is the physical properties. We'll talk about the boiling point of alcohol. So if you take ethane, and we're going to replace the hydrogen that I have highlighted right there, underlined, with a chlorine, you're going to get a huge boost, and the boiling point goes from negative 89 to 12 degrees. See here, I replaced this hydrogen with a chlorine over here. You see the boiling point, the huge difference that is. If you replace the chlorine with an OH, which I drew down here, again, you're getting a huge boost, which goes from 12 to 78 degrees. So I want you to know, the rhetorical question is, why do these seemingly small changes result in very large changes in the boiling point? So we have to remember this is due to intermolecular forces. And this is only capable of dispersion, the one up here, the first one I drew. And the second one is capable of dipole-dipole as well. And any alcohol, since it possesses an OH group, is capable of hydrogen bonding down here, which I've shown. Because of that, it's going to have a relatively high boiling point. So if you're asked to compare the boiling point, anything that has hydrogen bonding is going to have a higher boiling point, at least as far as this lesson is concerned. And it's just something to do with dipole-dipole interactions or dispersion. For the other two, it's a lower boiling point than hydrogen bonding. I hope that makes sense. And for the last part, we're going to be talking about deprotonating alcohols, which I've drawn over here. And for this one, for acidity, the main thing to focus on is factors that relate to the acidity of the alcohol. Acidity is going to be related to the stability of the conjugate base. In this case, it's going to be called an alkoxide ion. So how this negative charge on oxygen is stabilized by whatever this R group is going to determine the acidity of your alcohol. The more stable the conjugate base, the stronger the acid. And I'm going to look at some examples here. See, like a R group to a hydrogen has a high pKa, which is lower acidity. Then an R group to an NH2 group is going to have a lower pKa and a higher acidity. Then the R to the OH group is going to have a pKa of 17, which is lower. And as you can see all that here, there's different ways we get different products with different groups here. I hope you can see these reactions in the products that ensure. Thank you so much, and I hope this lesson taught you a lot about alcohols. Thank you.